And now this will be discussion panel between our guests today. The first one is Master of Science in Mechanics and Machine Construction, over 17 years in heat treatment experience, from the private side, singer and blues guitarist. Welcome, Marcin. Nice to meet you.
Hello.
Marcin Przygoński.
Hello. Nice
How are you?
Yeah, I'm great. Thank you. Pleased to be here with you
today. Great. And we are not alone here because we have our friends, maybe even thousands kilometers from here. And the first guest, Giovanni Parigi, which is degree in mechanical engineering, practical heat treatment experience since 1999, and actually production manager at commercial heat treatment shop at Staff. So Giovanni, hello and welcome.
Hello, nice to see you.
Yes.
Good morning to everyone.
Hello.
I'm very glad to be here.
Today in virtual way. Today in a virtual way, but it's better than nothing. So I'm very happy to see you here today, Giovanni.
Yes, virtual mode is the only mode.
Yes,
actually is.
And our third partner for today's discussion is graduated in Bachelor Engineering Metallurgy, 14 years of heat treatment experience and mostly focused on low pressure carburizing, Mr. Ramanathan Kartikeyan. Welcome.
Hi.
How are you today?
I am fine.
Okay. I feel like we all are almost in one place right now, so let's start our discussion. If you have anything to add, any comment, it will be only better for our discussion. So let's start with the first question. Today we are in new normality in every aspect of our life, also in the aspects of our business life. Supply chain in the new normality. How does the lack of certain types of steel may influence on heat treatment? Especially how does this affect the case hardening, Marcin? You are the first today, so please start.
Yeah, well, this is a very good question, I would say, and it is a very wide topic, but I can share a little bit of our perspective as a commercial heat treater from the Polish, let's say, market, and we can see clearly that recently there have been kind of problems with getting a proper steel grades, typically used for case hardening.
And typically used? What do you mean? What are typical?
For instance,
what was typical grades?
Yeah, 16 MNCR5 or 20 MNCR5, which are very common steels for case hardening, which we also do use and do heat treat them in under low pressure carburizing technology. And some of our customers are, as I mentioned, have been having problems with getting those particular steels. And from that perspective, they've been forced to change, let's say, possibility of getting and continues the production.
You cannot stop production, like car manufacturers.
Exactly, and therefore they've come to us saying, hey, how does it affect you know, the results that we are requiring from you? And we would say, okay, please let us know in which direction you are going, first of all, whether you're gonna do from 16 MNCR5 into 20 MNCR5 or the other way. And please give us an advice which kind of parts will it affect, because the main thing is that if you decrease the, let's say, the hardenability by changing the steel, then you have to consider this by parameterization of the process, yeah, you may end up with a situation that for particular, I'm not saying for all, but for particular parts, you might not be able to meet the requirements that are already set, yeah.
But having the lack of the materials, type of steel grades, you mean there is more change for lower hardenability steel? This is the tendency, or other direction?
Yeah, I would rather say that the change was actually from this particular experience we had. There was a change from downwards. I would say from higher hardenability into the lower hardenability.
That
and
makes the heat treatment more difficult. Many
exactly,
times.
and exactly, and I would say further on that due to this, let's say, problematic or problems with getting the particular steels, our customers had been chasing for different steel suppliers just to have enough steel to continue the production. And we had also a situation that, for instance, still they've delivered us exactly the same materials, exactly the same parts, and they were actually called the same materials. However, within the alloy content, we could have seen that some of them were at the, let's say, higher range of alloy content, and some of them were at the lower one. And the conclusion of that was that exactly the same part, and made of exactly the same steel, but with different alloy content, led us to, in the worst scenario, I mean the lower alloy content, we could not meet, for instance, core hardness requirements. And so this is another aspect, but which means that by changing a steel, I'm saying you may, I'm not saying you have to, but you may change your parameterization of process. And in the worst scenario, you might not be able to perform exactly the same as you had with the previous, let's say, preliminary settings.
Yes, and I think you may also change your procedure inside your workshop, also to make a better verification of incoming material, to check the hardenability, steel grades, the alloy content in a steel.
And further on, the tracking from the perspective of customers, tracking of the parts, which parts were made of this particular steel supplier and the other from different one. So that the tracking will also lead you to let's say pick up those parts which are with a higher risk not meeting the requirements after heat treatment. So this is really wide topic, and this is living topic right now within the Polish market. I'm wondering how maybe does affect the same situation we have on the other markets.
Gentlemen, do you see similar issues in your area with changing the steel grade for with requesting the similar final properties of the material after heat treatment?
So we have a similar problem also in Italy, but from my point of view, I've seen that the principal problem is that this situation creates delays. So when you have delays, you have to run, and then you are always in a hurry. And this is the big problem, because if you are in a hurry, you can make mistakes. But this is the biggest problem that I have actually about this problem of difficult to find the correct steel, that our customer have to wait a lot of time, and then we have to hurry. So this is the principal problem, but I also find a similar problem that already told before, of that they use customer have to use a lot of suppliers, so we have material mixed, and you find strange problems during heat treatment because some pieces are in a way, other pieces are in another way, and it's not so easy to have all the materials very well divided one by one. So
the new normality elevated the heat treatment at the highest level, of the complication.
Yes, and on our side, I have sometimes with some customer that I know that they have this problem, that I try to use some check during the heat treatment, example, after quenching or after the first tempering step, in order to be sure and then to adjust the other step of treatment to have the correct value at the end.
Okay.
This is I mean, this is another aspect. It is possible, to let's say try to heal, to get the proper results But the question is on which stage, you know, if everything is okay or not, you know what I mean? And that's another aspect. Sorry, Adam.
Please.
Communication. You know, if there is a communication, I believe we may avoid massive issues
in
within
this
the
way.
heat treatment.
We can return to one of our previous presenter, Carlos Humberto Sartori from Villares Metal, and he explained perfectly about the importance of communication. So even before we even start the heating or we start the process.
Yeah.
So great. Yeah. Thank you, gentlemen. Let's switch for the next question, and the next question is related to carburizing or case hardening processing limits. So is it more the matter of a charge weight, or is it more a matter of a surface area? Kartikeyan, it's now your turn. Please say, how do you see this? Okay, one moment, please. We do not hear you well. I don't know what's happened.
In case of vacuum carburizing, we feel that particularly the surface area plays a very important role in case of carburizing in vacuum, because weight, almost every furnace manufacturer defines a certain weight. But when it comes to vacuum carburizing, the flow of the gases are limited, and so surface area plays a very important role. And with the smaller components, the flow has to be taken care well enough so that the entire gas flow reaches till the middle for some triple chamber bigger size furnace, around 1200 kgs. So in our opinion, surface area plays a major role in vacuum carburizing.
Yes, I fully agree, and I can only add to this that from my perspective, my point of view, this gas flow, it's not only parameter, but it's more the combination of the gas flow and pumping system efficiency versus the volume of the hot zone and number of parts inside. So it's always not the easy calculation or estimation before we start, basing only on the surface area. But I agree, and this is sometimes it's also if we talk about communication, it's hard to explain to our customer that the limit it's not the kilograms in the charge but the surface area, and it's good to generally know. And from your point of view, when you receive the components for the carburizing, do you have some information about surface area on the drawing, on the specification, or you have to calculate it by your own?
No, actually we are in-house heat treaters, so we have a communication with our design engineers. So based on the software, they will give the surface area. So when any new product, we work with the surface area data available, and based on that we decide the gas flow. And whatever the cycle is made by us, we one more time reconfirm with the Seco Warwick R&D team, and once confirmed, we validate the entire process at 9 locations for surface carbon, hardness, as well as heat treatment parameters. And once the process parameters are established, and then we don't change anything, and we try to achieve by maintaining the same parameters.
Yes, great. Thank you, Kartikeyan, for this answer. I mean, if anything to... Yes, please.
Yes, well, if I may.
We are here for discussion.
Yes, exactly. I would have guessed so. This is true. Actually, I agree totally with Kartikeyan regarding the surface hardness. That is surface area. That this is the key point, because I would say the other way. The furnace will limit the weight, and the system, the carburizing system, will limit the surface area. Yeah, so that you can conclude in a one sentence. But I would like to mention one aspect. As a commercial heat treater, we, there are situations that the awareness of our customers may differ, right? So those who are aware of the benefits and the requirements for low pressure carburizing, they are aware that they have to provide the surface area for us in order to run the process accordingly to the requirements, etc., etc. But for those who are not necessarily are aware and they are used to, the traditional technology, which doesn't actually require knowledge of it. It is helpful to know what is the area, but doesn't require. Then we have to, then we have to explain them how and why this is so much important, right? So yeah, this is very key point, I would say, from the perspective of low pressure carburizing. Yeah.
Yes. Thank you so much.
Can I tell another thing?
Of course, Giovanni, please do.
Yeah, from my point of view, we have a lot of small parts of some customers to be put on the same load.
Yes, the
so
mixture.
A
Combined
mixture.
loads.
When one of the problem is that about the pressure, the cooling that you cannot forget the problem of pressure of the cooling to obtain the correct value. Also hardness, also of depth of hardness. So this is another point that I have to focus every time, because our customer obviously ask for lower distortion. So the easier way to lower distortion is to reduce the pressure of cooling during treatment. But it can create a problem of not correct value of carburizing depth or in the worst situation of also hardness.
Yep.
Exactly. I fully agree. It's a completely different preparation of the load, which is
Identical
and completely different as in your case. It's a mixture of different parts with different cross sections and different even requirements sometimes. So thank you for this input.
And here comes the practice of doing such combinations. Knowing your feasibility, knowing feasibility.
We speak about limits.
Yes. Well,
but by the way, when you explain your experience, I was thinking about opposite situation where we have a protecting paste in a load, and because the main discussion was about the limit in the surface area, so the maximum number of square meter in one load.
Yes.
But there is the opposite situation when we have big components. 90% of the gear can be protected by the paste, and we have very small area for carburizing, and this is another subject, but this is some just additional comment. So let's go for the next question we prepared, and this is really interesting to me because sometimes it's not so simple to resolve, and this is about packaging transportation issues versus the quality of components that are arriving to the heat treatment shop, and how the quality of details for carburizing mostly, and how about the surface quality before the process. So, Marcin.
Another wide topic, which I don't think we can, finally conclude.
Yeah.
But this is another important aspect, I would say, and the surface quality of the parts before heat treatment plays a key role. Starting starting from the surface area, for instance, and ending on the quality report, I would say, whether the parts are okay or not okay. Yeah,
accepted or rejected.
Exactly. Knock or ok. I would say, and in many cases, on every stage of the, process flow, let's say the parts may be damaged in higher or lower level. However, from our perspective as a commercial heat treater, we play a key, let's say, point to the checking of the parts at the enter, let's say, enter door, I would say. Yeah. So that we are sure that whatever we receive or whatever we will let's say heat treat any damages were not caused by us, right?
Yes.
So first of all, we check whether the parts are correctly, let's say, packaged. If there are any potential situation that the parts will damage during the transportation, etc. And of course, further on, this is on our response to let's say configure the process, the parts flow through the heat treatment shop to avoid any of that such situation, starting from configuration of the charge, right? So using, for instance, gloves, right? Not letting the parts stick to each other, yeah? Getting the proper fixture for particular parts, whether this is, hanging or laying, or, how to configure them to not allow them, for instance, to damage during the quenching, for instance, which is very, very
Delicate,
powerful.
and
Yeah.
powerful. But this is about the heat treatment when you already receive the parts and
Yes.
Start the heat treatment. But before, what are the most popular defects you can observe on?
I mean, I would start with
traveling?
nicks and dents. Yeah, this is a typical by not proper handling of the parts. Yeah.
And is it anything that can be repaired before or
No,
during
I mean,
heat treatment, or the
well,
parts are?
No.
you
I
know,
mean, it's defined. I mean, each customer defines based on a catalog of defects of parts which are okay or not okay. Yeah. So it relates to the areas which has to be defined, which are okay or which are acceptable and which are not acceptable. Yeah. So we cannot generally say that for instance, scratches are totally eliminating the parts from the further production. No.
Okay.
Yeah. Yeah, well,
I'm okay with this answer. And
okay.
By the way, because Giovanni and Marcin, you represent commercial heat treatment companies, and Kartikeyan, you represent your own heat treatment inside the company, Sundram. And do you see the same or similar issues when the parts are coming into heat treatment shop that were maybe not properly packaged or transported, or it's better or easier to control this issue if everything is under the same roof, let's say?
When your products are standard, then you can make a dedicated fixtures and you can handle on that, and you can avoid the dents and damages on the components. So since we use similar products, so we have a dedicated fixtures, but still we are not able to avoid the nicks and dent mark. They are coming up to 2 to 3%, which are coming from the other processes. But still at the end of line, we try to rework and then use the components.
Especially if you're running like Giovanni said, that now everyone needs to be in a hurry. Yeah. So in a fast delivery, the risk of damaging the surface it's even more.
Hurriness doesn't help.
Yes, Chad, this is a very big problem. I want to focus another aspect that I try to tell to our customer that, okay, correct packaging to avoid damages is okay, but it has to be also fast to unpackage and package from my point to give
exactly
back, because it is a cost. It is an important cost. True. At the end.
True.
So I know it's not so easy to have the correct situation, but it's an important aspect that we have to focus also on this.
It's really interesting because everyone are focused on his responsibility. Yes, machining about the machining, heat treatment about the heat treatment, but the between connection is really critical sometimes.
I mean, there's a lot of things going around the heat treatment itself. Yeah, like we are saying, the packaging and the time that is needed to unpack proper way and then pack again the same way.
Simple issue, but not so simple. Just theoretical. In practice, it's more.
Yeah.
Okay, thank you, gentlemen. Let's go for the next issue and check what's happened. So the next issue is a little bit connecting with this because it's about surface roughness, and especially if we speak about low pressure carburizing, we have different surface roughness, depends on the production way of the parts. So Kartikeyan, please tell us your experience in this case.
Based on our experience in the past 3 years, we have found out that surface roughness plays an important role in carburizing. So whenever the surface roughness is very fine or smooth surfaces like machined surfaces and finished machined surfaces, they react to heat treatment well, and we get the desired results as per the parameter set. But when it comes to rough surfaces, there is slightly carbon accumulating more in that location. So this we have trialed out by reducing the partial pressure during carburizing. So in this case, for the rougher surfaces, slightly lower partial pressure helps to sort out the issues. So when the surface is smooth, the results are pretty good. In rough surfaces, the results has to be achieved by adjusting the process parameters during carburizing, especially the partial pressure.
Okay, and when
if I may, and have you checked if any let's say temperature decrease or increase, I would say rather decrease, would help to let's say to avoid such a situation? Have you been checking this, or you took it as a constant?
We have trialed out at various temperatures 940, 950 and 960, but we found that rough surface attracts more carbon easily compared with the machined surface. Also, the removal of carbon from the surface by pumping is easier on machined surfaces, but the rough surface, it takes a little bit time. So some of the parts at center, very small parts, sometimes it is very difficult. So we adjusted the partial pressure of the carburizing and we eliminated these kind of issues.
Yeah. But if you may to decide what parts are, let's say, easier and with a better quality for at the end of carburizing, do you prefer the parts after machining or after forging?
Parts after machining will give better and best results, repeatable results. In forged condition, if the components are slightly thinner or there are sharp corners with rough surfaces, then there is a possibility of accumulation of more carbon.
Okay, thank you so much. And let's go for the next subject. So far, so good, but the time is flying now. And very also, let's say, wide subject, deformations, and what are the tips to limit them in heat treatment, especially after the carburizing? And I'm watching you, Marcin.
Yeah, I'm glad that you said to limit them, not to eliminate them, because you cannot eliminate
or to make it more friendly.
Deformations. Yeah. I mean, why I'm saying this, because, every time, or very, very often you got a question if you can avoid deformation, yeah? And the true answer is you cannot do this. You can somehow try to minimize them, yeah? And this is wide topic. I mean, to make it any worth conclusion, we would have to consider some particular parts, some particular configuration of the batches, and because only then you can take particular conclusions how you can limit them. But I know that this is an open panel, but
may I ask you one thing?
Yeah.
Because you are representing company that is heat treating hundreds and thousands of parts per month.
Yes.
We produce heat treatment equipment as a Seco Warwick, and many times if we have a not fully confident customer or the potential customer that is looking for some benefits that can be achieved after high pressure gas quenching, people are trying to make some tests, and many times we do tests and trials that are made on 3 components, and sometimes some dummy loads, sometimes some ballast material. But from the practical point of view, it's really hard to make a 1, 2, 3 fully packed load that are representing exactly the productive load. And do
But
you see
that-
any differences
Yes,
between the...
that makes the difference.
Yes,
I mean the loading of particular parts makes the difference. If you load, you know, just a few, as you mentioned, 5 pieces of particular parts, even if you load together combined with some other dummy load, I would say, you might not get the same results in terms of deformation if you would then compare these results from the ones if you had identical parts within the whole batch. Yeah, and that may gives you the wrong picture, yeah, of the deformation, which you can really get. And further on, of course, this is just a pilot. You may also do a lot of things with starting with the fixturing, with the configuration of parts, with the gas quenching parameters in order to optimize this process.
Kartikeya mentioned about the important issue when there is a repeatable production.
Exactly.
We can produce dedicated fixture even for the, maybe not only for the pilot, but for the serial production. If you have different parts, like also Giovanni, sometimes mixing load.
Yeah.
It makes it more difficult.
There's a lot of things. I mean, you know, from the point of view of identical parts, you know, the massive production, you may optimize them, yeah. But another case is if you have to combine different parts, yeah, how to do it, how to avoid those things, especially if your customer requires not to, you know, produce a big or greater deformation. And then what we can say is practice. You know, you have to practice. You have to think about it and look on the parts from the perspective of the, let's say, how they are prone to deformate, yeah, and in which areas. And then considering this, knowing the feasibility of your equipment, then you can try to find out the most optimum way. But on the other side, I would say, of course, production of massive production, as we do, not necessarily in the low pressure carburizing system, but in the atmosphere type furnaces following oil quenching, we do use also the straightening procedures, yeah. So this is another aspect.
As a chain of the complete heat treatment.
Exactly. Yes. So you do the case hardening, oil quenching, and on some stage there is a straightening of parts, yeah.
I have a feeling that for many customers, the deformations may be acceptable on conditions on condition that they are repeatable. Don't you think?
Yeah. Because having the repeatability of the deformation allows you to pre-program the soft machining and further on the hard machining, so that you are within acceptable tolerance.
Yes.
And then you are on the good way.
Good, thank you. Yeah. Anything to add, gentlemen? Would you like? Or we switch to another subject?
No, I just want to focus that about distortion. I normally try to focus on all the parameters that can affect the distortion. I try to discuss also about geometry of the pieces.
Yeah.
If I have a parts with a strange hole, a different of shape, a big difference of shapeness, I just talked before, it's impossible to reach a good results. So I think that to minimize distortion, we have to put on the table all the parameters that can affect, can create this problem. But from my point of view, what I make, I try to find, yes, the best parameters of fixturing and gas pressure. Okay, this is very difficult, but you have also to discuss about the geometry of the parts. Sometimes it's not possible to reach a good results, and we know before to put them in the furnace.
I like what you said, Giovanni, because when the person with such experience like you see the parts before heat treatment, I can imagine that you know exactly that, oh, this is a trouble, or okay, we can do it easily, because like you said, asymmetrical components and so on. And this is also, I agree with you that it's a combination not only with quenching parameters, but also with proper load arrangement and professional fixture. Yes?
Yes, exactly. What I want to say that if distortion are a problem, customer have to put also himself that he can create distortion by machining by a not correct type of geometry.
Yes.
Exactly.
Unfortunately, many of distortions are visible only after the heat treatment, even that the reason was
Before.
in some process before.
Yeah.
It's a hard
Exactly,
life of heat treater. Okay. And the next question, if you don't mind, it's regarding the difference in process preparation when we carburize small parts, small components. So big number of components in one load. And now I watch on a Kartikeyan. Please share your experience in this case.
When you are processing very small parts, we have to see that the uniformity is being maintained from the surface to the center. So in case of small parts, the more amount of gas flow is required. So we have to decide the gas flow based on the surface carbon at the center of the parts. So in case of bigger parts, it is easy to determine the gas flow. But in smaller parts, you have to determine the gas flow in such a way that you have to attain a surface carbon at the surface. So you have to minimize the final diffusion time in case of small parts to maintain the surface carbon, or you have to increase the number of carburizing cycles to maintain the required surface carbon. So in case of small parts, you need to achieve the specified surface carbon, you have to decide cycle accordingly. So this is our experience, and based on that we are working. So for big parts we give lower gas flows, and for small parts higher gas flow initially and lower diffusion time.
Okay, and when you say small parts and big number of parts, what quantities do you mean?
So
more or less.
In our case, more or less about 25 meters square of surface area.
Yes, and how many parts in one load?
Around 2,200 to 3,000.
Yes, 3,000 components in one load for low pressure carburizing is a challenge.
Yes, 3,000, 3,300.
Yes, and 3,000 parts made by forging with big requirements for the deformation, it makes even more difficult. But thank you, Kartikeyan.
In our experience, we have even faced distortion in different raw materials. If we buy from one source, the distortion is of one type. Another source creates a different distortion. Yeah. So from raw material to end, distortion plays a very important role.
Yes, I heard one day from one of my friends that if possible, there is normalizing suggested before to make the load or different parts less sensitive for different conditions. Do you have such experience?
No. For us, additional operation creates additional problems like dent damages. So we don't prefer additional operations. And only in specific cases where we require additional operation, there only we try to do additional operations like normally.
I can understand, because additional operation is additional cost, and if not necessary, nobody wants to pay more. Okay, so switch for the next question, if we can, because I'm just also watching on our counter, and yeah, that was the last question. So, gentlemen. It was really fast.
Yep.
The time. And how do you feel right now after this discussion?
Good. Martin? I would say yes. We've shared just our perspective. In some, we are absolutely on the same path. So I'm happy that it's not only touches us, but also it touches everybody. The same problems, but in different time zones. I would say
it means it doesn't matter of the location.
Yeah.
We face the same heat treatment issues every day.
Yes.
Giovanni, how are you after today's discussion?
Very well. Yeah.
Anything surprised you?
I'm very happy. I'm very happy to find that my problems solve everyone problems.
Yes.
So I don't know. It makes me feel better, but
Okay, great. And Kartikeyan, how are you?
Yes,
Anything to
so
say for the final
okay.
word?
Okay, in your cases, you have steel crisis. In India, only one advantage what we see is we maintain enough stocks. We don't work with limited WIP. We keep more stocks. So we face very less issues due to raw material and other variations in the process. But still we have certain issues of distortion that by experience we are learning and we are correcting and we are progressing.
Yeah.
Thank you so much, gentlemen. I'm really happy to see you here and to have a pleasure to talk to you today. Especially that it's great to share and to hear your tips or your personal experience. So thank you, Marcin. Thank you, Giovanni, and thank you, Kartikeyan, for this discussion panel. And to all of attendees of our seminar, I must say, big thank you, and I hope to see you in the next year.